Let's talk about models now. There are three models we will look at: the univariate linear model, the multivariate linear model, and the mixed linear model. All of these models have a common structure. First of all, a model is a simple statement about the population in general. We kind of generalize from the sample we observe to a population we hope it represents. The structure looks like this. The response is equal to some sort of prediction plus an error. We use data from the sample to find estimates of parts of the model. We observe the response values or outcomes. The univariate model only has one single outcome measured at one time. These models only work with uncorrelated data, which means no clustering is involved and there's only a single outcome measure. As we just talked about when referring to repeated measures, the multivariate model is to explore multiple outcomes. This can include repeated measures at different points in time, multiple outcomes measured at just one point in time, or multiple outcomes measured repeatedly at different points in time. These can get complicated. The mixed linear model is used for experiments with outcomes like the multivariate model, but it is a more flexible model. When we say more flexible, this is because it makes fewer assumptions, so it can be applied to more situations. The major difference here is that the mixed model can more easily accommodate missing data, a topic that we will discuss later in this course, than the multivariate model. Unlike the univariate linear model, the multivariate and mixed linear models are used for correlated data. Once again, correlation can be a result of clustering or repeated measures. So multivariate and mixed models are used for all kinds of combinations of these things, like one level with multiple outcomes, multiple levels with one outcome, or multiple levels with multiple outcomes. Now we are going to look at a couple of hypotheses. These differ the same way the factors with the same names differ. You'll see what I mean in a minute. Within independent sampling unit, hypotheses explore changes over time or space. The example here is measuring the pain level of every patient for 6 weeks following a procedure. We have a single group and we want to see how pain changes over time. You can see in the graph that the average pain level for the group appears to decrease over time. Between hypotheses explore differences between groups. Keeping with the pain example, we might be interested in knowing whether sensory focus group had a different average level of pain than the standard care group. In this graph, you can see the standard care group appears to have reported more pain than the sensory group. Most commonly, however, there will be a combination, a within by between hypothesis. This kind of hypothesis explores how an outcome changes over repeated measures, like time, between groups. In this graph, you are able to see the sensory group has a lower average pain level than the standard care group, and you can also see it decreases over time. As you can see, we are able to look at patterns over time across treatment groups. Let's do a review summary of what we learned in this lecture. We aim to use models that represent reality as closely as possible. They take inputs, or are independent variables we are interested in, and based on those values, those inputs, they predict what values of outputs will be, the dependent or outcome variable of interest in the study. In this course, we talk about the univariate linear model, the multivariate linear model, and the mixed linear model. We use the predicted values from one model to inform the hypotheses tests we explore in other studies. We can explore between hypotheses, like there will be no difference between the outcomes of participants in treatment A and treatment B. within hypotheses like there will be no difference in daily miles walked over a 3-week period, and we can explore interactions or within by between hypotheses like there will be no difference in the pattern of daily miles walked over the 3-week period based on the participant's treatment. That wraps up this lecture. Thank you for your time and effort.